This video will cover some common security concerns in our LANs and some best practices in order to protect our LANs from attacks and make them more secure. We want to make our switches as secure as possible. Securing our switches is going to lead to a more stable network with higher uptime and a better user experience. It will also help us lead to our ultimate goal of having a borderless network. Some common security risks include MAC flooding. With MAC flooding, an attacker attempts to overload our CAM or our MAC table so that all traffic that hits a switch gets flooded out every single port. DHCP spoofing. DHCP spoofing happens when an attacker configures a fake DHCP server on the network to issue DHCP addresses to clients. The normal reason why an attacker would want to do this is to give all of your clients on the network false DNS information so that they can potentially be sent or redirected to fake websites or become bots that can be controlled. Other attacks include CDP attacks, where we use Cisco Discovery Protocol against our routers and switches. Telnet attacks, where we take a look at our usernames and passwords being sent over in plain text, as Telnet does by default. Or brute force attacks, where we attempt to crack passwords on our devices by sending password after password after password to the device until it finds the correct one and cracks it. Using some of the best practices discussed in Chapter 2 help thwart some of these security attacks mentioned in the previous slide. Some of these best practices include shutting down all unused ports on the switch. Shutting down unused ports on the switch will lessen your attack surface that you have on those switches. Using strong passwords, using SSH remote management instead of Telnet, keeping our devices up to date with operating system updates, encrypting our data when possible, using port security so that only certain devices can connect to our ports, and using DHCP snooping to look for rogue or fake DHCP servers on the network. Securing unused ports. A simple method to help secure a network from unauthorized use is to secure the unused ports. This is actually a very easy way to lessen the attack surface that you have on your switch, and it only takes a few commands. The easiest way to do this is to use the interface range command. Type in the range of addresses that you want shut down and shut them down. Best practice is to shut down every single interface and then only turn on the ones as they're needed. DHCP snooping. With DHCP snooping, you specify which port the trusted DHCP server is plugged into. This port that the real DHCP server is plugged into is known as your trusted port. Trusted ports are either going to host the actual DHCP server or an uplink that's eventually going to get you to the trusted DHCP server. All DHCP requests from untrusted ports would not be responded to. Only DHCP requests from the trusted ports are responded to. So with the case of DHCP snooping, if a rogue or fake DHCP server gets plugged into the network, it would be plugged into an untrusted port, the port would be shut down, and no DHCP requests could be answered from that port. Here's an example on how to set up the DHCP snooping. In this example here, we have our trusted DHCP server on port fast Ethernet 01 of switch 1. Port fast Ethernet 01 on switch 1 and port fast Ethernet 02 on switch 2 should be trusted ports. These trusted ports either directly connect the DHCP server or in an uplink from one switch to the next to ultimately get to our DHCP server. The other ports on switch 2 are untrusted ports, meaning that if any DHCP servers got plugged into these ports, they would be shut down and DHCP requests would not be responded to. So in global configuration, we turn on DHCP snooping. We set the VLANs in which we want DHCP snooping to happen on. We go into our interfaces that are trusted ports and issue the IP DHCP snooping trust command. And then additionally and optionally, we can issue the IP DHCP snooping limit rate. What this does is this prevents the amount of fake DHCP requests that an attacker plugged into an untrusted port can make towards the DHCP server. Usually with a DHCP rogue attack, what will happen is the attacker will first try to run the DHCP server out of all of its addresses that it has available to give out. So it would continually send requests out to the DHCP server until all the addresses are gone. It would then attempt to start up its own DHCP server and give out addresses to everybody else on the network, or the next people that ask, or the next computers that ask for them. So setting this limit is only going to allow him to send one request every 5 seconds to that DHCP server for an address in his attempt to use up all the addresses that that DHCP server has in its pool. I'm going to skip past the port security slides in this particular video, as I have another video posted that goes through the port security concepts. Last thing to talk about from this slideshow is NTP, or Network Time Protocol. It's important to have correct time within our networks. Having correct timestamps will allow us to accurately track security violations, view our system log events, and make sure certificates work properly. NTP is a protocol that allows our devices to synchronize their time settings with an NTP server. This NTP server can be an internal time source, or it could be an external time source. Some of the time sources could be a local master clock, a master clock on the internet, or a GPS or atomic clock. A network device can be configured as either the NTP server or as an NTP client. To configure a router as an NTP server, we use the NTP master command with a stratum number. I have a link down below that explains a little bit about what the stratum number is all about. But basically what the stratum number is how close you are to the master clock. Then in order to set up a client to sync against the master server, or the NTP server, we use the NTP server command and then its IP address. In this example here, we are going to set router 1 as the NTP server. And there's a typo here. This is say R1. So R1 in global configuration is going to do NTP master 1. That's setting it up as the master NTP server, and any devices could sync their time against that server. Then the client R2 on the bottom there is going to do the NTP server 10.1.1.1 address. That's telling it that the NTP server on the network has the IP address of 10.1.1.1, which is R1's IP address. So then what R2 would do is it would sync its time against R1. All other devices on the network, you would want to issue the NTP server 10.1.1.1 command as well, so that they're all syncing from the same device on the network. There are a few commands that we can use to verify NTP. One is the show NTP associations. This will give you the IP address of our NTP server, and it will show us some detailed information about that association with the NTP server. Another command is the show NTP status. This will show us who the NTP server is again. It will show us whether or not we're synchronized, our stratum level, what the actual time is set, if there's any offset or delay, and tells us the last time that an update occurred to get the time. That's all for this video on security concerns and best practices in a switched environment. Thanks for watching.